Good morning everyone. So today let us see problems on Newton's forward and backward interpolation formula. So already we have seen the formula basing on Newton's forward and Newton's backward. So see the problem here. The following table gives the distance in nautical miles. So of the visible horizon for the given heights. In feet above the earth's surface. So this is the data given. I will write it vertically. X, it is height. And y, it is distance. So that is what given for us here. So height is 100, 150, 200, 250 and 300, 350 and finally 400. So corresponding to height, the distances are 10.63, 13.03, 15.04, 16.81, 18.42, 19.90 or 19.9 simply, 21.27. So they asked us to calculate the values of y when find the values of y. So here our aim is to find, let us prepare the difference table there. Find the values of y in two cases. When first case x is equal to 160 and second case x is equal to 410. So in those two cases we have to find what is the value of y. X is equal to 160 and x is equal to 410. So basically now we have to see. So this is definitely in your question paper. This question will be in under unit 4. So you can understand this is related to unit 4. And what are the topics you had in unit 4 is Newton's forward interpolation formula, Newton's backward interpolation formula, Gauss forward, Gauss backward, Lagrange's. So for the given data, which formula suits well is based upon the intervals. So whether it is equally spaced or it is unequally spaced. If it is equally spaced, what are the formula suits for equal intervals? Gauss forward, Gauss backward, Newton forward, Newton backward. So we can use those four formulae. But Lagrange's it suits only for unequal intervals. So now let us see the intervals. So these are arguments. We call them as arguments. Not argument, argument. So these are entries corresponding to x. Whatever are the values given, we call them as entries. So first let us see how are the values of arguments spaced. See the difference between 100 and 150. Difference is 50. Difference between 150 and 200. It is 50. So like that for all these, what is the difference? 200 and 250. Difference is 50. 250 to 300 difference is 50. 300 to 350 difference is 50. And 350 to 400 difference is 50. Means they are equally spaced. They are equally spaced. So what is the formula that suits now? Now see what is the value asked. For what value of y, or find the value of y when x is equal to 160, x is equal to 410. So x is equal to 160. Where is x is equal to 160? It is at the top of the table between 150 and it is between 150 and 200. 160 is between 150 and 200. So it is at the top of the table. So when do we use Newton's forward interpolation formula? When the value which we have to find is at the top of the table. So 160 is at the top of the table. So we will use Newton's forward interpolation formula. Why we are using Newton's forward? Because they are equally spaced. Now see second case, x is equal to 410. Where is 410? At the bottom of the table. 410 is at the bottom of the table. So for this we have to use Newton's backward interpolation formula. So now see, before applying the formula, we have to prepare the difference table. Difference table we have to prepare. So for that, what is that required? First forward difference table is we write it as delta. Next, we need second. How many values were given here? We were given 1, 2, 3, 4, 5, 6, 7. So we get 6 forward difference here in the table. 6 for up to 6th forward difference we get. So del square, del cube, third forward difference, fourth forward difference, fifth forward difference, and sixth forward difference. That is what we get here. So now let us see the difference table. So how to prepare difference table? So how much is 13 minus here? 13 minus. So we call them as here. This is called x0. This is x1, x2, x3, x4, x5, x6. So this is correspondingly y0, y1, y2, y3, y4, y5, y6. So now first forward difference. So here we get all these y1 minus y0. So what is that we get here? First forward difference, first value y1 minus y0. y1 minus y0. So what is the value we get here? y1 minus y0. See, 13.03 minus 10.63. So it is 2.4. So where you have to write? You have to write exactly to the middle of these two values. So it is 2.4. 2.4. Next value should be here. Means y2 minus y1. See its value 15.04 minus 13.03. So how much is this? It is 2.01. So here we have to write 2.01. Next value y3 minus y2. So this is 16.81 minus 15.04 is equal to 1.77. So all the time you have to write to the middle of these two values. Next 18.42 minus 16.81. So it is 1.61. 1.61. Next 19.9 minus 18.42. 18.42. It is equal to 1.48. Next, last one, 21.727 minus 19.9 is equal to 1.37. 1.37. So now see, so y1 minus y0. So we will call it as del y0. So for forward difference table, we start writing from top to bottom. Del y0, this is del y1, this is del y2, del y3, del y4 forward operator, and this is del y5. So the values will be decreasing as we go towards the table. So next, second forward difference. This time here we have to subtract again this value from this value. So now see what is that we get here. 2.01 minus 2.4. It is minus 0.39. Next, 1.77 minus 2.01. It is minus 2.24. Next, 1.61 minus 1.77 is equal to minus 0.16. Next value, 1.48 minus 1.61 is minus 0.13. Next, 1.37 minus 1.48 is equal to minus 0.11. So now we have to name them. Because these are second forward differences, we call them as del square. Del square y naught, del square y1, del square y2, del square y3, del square y4. So if you observe, the values will be decreasing. We started with y6, next y5, y4, we end with y3 in the next one. So now see the next forward difference, third forward difference. This time you have to subtract. See the sign, be careful with the sign. Minus of minus, this becomes plus. Means we have to write 0.39 minus 0.24. So it is 0.15. So here it is, we have to write to the center 0.15. Next, minus 0.16, minus into minus, this becomes plus, means 0.24 minus 0.16. So this is equal to 0.08. Next, 0.13 minus into minus plus, so this becomes 0.03, because 16 minus 13 is 3. Of course, this becomes 0. Next, minus 0.11 minus into minus plus, so this becomes 0.02. 0.02. Similar. So this is called as here, this is del square del cube y naught. This is means del square y1 minus del square y naught is del cube y naught. Already we know this. Del cube y1, del cube y2, del cube y3. Right. Next we calculate fourth forward difference, means 0.08 minus 1.5. So 0.08 minus 0.15. So this is minus 0. We have to write to the center, minus 0.07. Next, 0.03 minus, this time this value, 0.03 minus, so minus 0.05. This one, 0.02 minus, so we get minus 0.01. So here we call this as, this is del power 4 y naught, and this is del power 4 y1, and this is del power 4 y2. Next, fifth forward difference. This time minus 0.05 minus of minus plus. So this becomes 0.02. Here minus 0.01 minus of minus plus, that becomes 0.04. Finally, so here we call this as del power 5 y naught. This is del power 5 y1. Next, sixth forward difference, 0.04 minus 0.02. So it is 0.02. So this is called as del power 6 y naught. So this is the forward difference. So now in order to find the value of y when x is equal to 160, we are going to use Newton's forward interpolation formula. So here let us see the formula. Newton's forward to find y or y of x, you can call, when x is equal to 160. X is equal to 160. So here we use Newton's forward by Newton's forward interpolation formula. So what is that formula? Y of x, or even you can call it as f of x also. Y of x is equal to y naught plus p del y naught plus p into p minus 1 by 2 factorial into del square y naught plus p into p minus 1 p minus 2 by 3 factorial into del cube y naught plus so on. So how far we have to write here? Observe here. How many forward differences we got? We got up to 6th forward difference. So we have to write up to del power 6 y naught. So plus p into p minus 1, p minus 2, p minus 3 by 4 factorial into del power 4 y naught plus p into p minus 1, p minus 2, p minus 3, p minus 4 by 5 factorial into del power 5 y naught. Finally, one more step, plus p into p minus 1 into p minus 2 into p minus 3 into p minus 4 into p minus 5 by 6 factorial into del power 6 y naught. So this is, but it goes on. So since we need all the other forward differences are 0, we had up to 6th forward difference, we need formula up to this term. So now what is p? Where p is equal to x minus x naught by h. X minus x naught by h. So what is that we have to find here? For what value of x we have to find? For x is equal to 160. Means here x is equal to 160 minus. What is x naught? Already here we have seen x naught is 100. 160 minus 100 by h means difference interval. What is the length of the interval? 100 minus 150, 50. So it is equally spaced with h as 50 by 50. So this turns to be 60 by 50. So it is 6 by 5. So 6 by 5, let us see. It is 1.2. So our p is 1.2. P is equal to 1.2. Now we will substitute in the formula. Therefore, y of x means, where did he ask us to find y? Y at 160 is equal to y naught. So from the table, all the values, if you observe here, all the values are top values. Y naught, del y naught, del square y naught, del cube y naught, del power 4 y naught, del power 5 y naught, and finally del power 6 y naught. All these values we are going to use in the table. So substituting those values in the table, let us see. Y naught. What is y naught? 100. 10.63. 10.63 plus p is 1.2. Del y naught. Del y naught is 2.4 into 2.4 plus p into p minus 1, 1.2 into 1.2 minus 1 by 2 factorial is 2, del square y naught. Del square y naught is minus 0.39. Minus 0.39. Next, substituting in this, p 1.2, 1.2 minus 1, 1.2 minus 2 by 3 factorial. 3 factorial is 6. Del cube y naught. Del cube y naught is 0.15. Next, coming to this term, plus 1.2 into 1.2 minus 1, 1.2 minus 2 1.2 minus 3 by 4 factorial is 24 into del power 4 y naught. Del power 4 y naught is minus 0.07 plus next term 1.2 into 1.2 minus 1 into 1.2 minus 2 into 1.2 minus 4. Okay, 1.2 minus 4 by 5 factorial is 120 into del power 5 y naught. Del power 5 y naught is 0.02 plus next last term here. P is 1.2, 1.2 minus 1, 1.2 minus 2, 1.2 minus 3, 1.2 minus 4 and 1.2 minus 5 by 6 factorial 720. So del power 6 y naught is 0.02. So if you calculate term by term, you will get the answer as 13.46. 13.46. So now see where is 13.46. We are calculating at 160, means the value, your answer should be between 13.03 and 15.06. So we get 13.46.